In the diagram, O is the center of the circle LMN, and angle LNM is equal to 38 degrees. The line PN is tangent to the circle at N. So here we have the diagram. Calculate the value of angle LMN. And so that's the goal. We need to figure out what is the value of angle LMN. And so let's identify this angle. So they want us to figure out the value of angle LMN. And so what are we looking at, right? We're looking at, or we're zeroing in on this particular triangle. And so, and what they really want is they want the angle that's in the middle, right? So we're looking for the size or the measure of this angle right there, angle M, okay? Okay, so what is the size of that, right? In order to figure out the size of this angle, what we're gonna do is we're gonna use this theorem, angles in a semicircle. It states that the angle in a semicircle is 90 degrees. And so notice that we have the diameter AB, and the diameter AB cuts this circle into two halves, right? So this is a semicircle, and this is a semicircle. And the angle that is in a semicircle is 90 degrees. And we have the same thing here, right? We have the diameter LN, and this divides the circle into two halves, this half and that half. And this angle M is the angle in a semicircle, and this angle is 90 degrees. And so the angle or the size of, or the value of angle LMN is equal to 90 degrees because of angles in a semicircle theorem. Next, we have to figure out what is the size or what is the measure of angle MLN. And so let's do that. Let's first identify that angle. And so we have to look at MLN. So this is M, this is L, and this is N. And so we're looking at this particular triangle, all right? We're looking at MLN. So we're really zeroing in on this particular angle in the middle, angle L. And so our goal is to determine, okay, what is the size of this angle right there? Angle L, all right? Now, what do we know? We do know that angle M is 90 degrees because of the previous answer to our question. We do know that it's 90 degrees, all right? 90 degrees, let me fix that. This is 90 degrees, 90 degrees, and the box indicates that size of a 90 degrees, okay? And so how are we gonna figure out what is the size or what is the measure of angle L? Well, notice that we have this particular triangle, all right? And angles in a triangle add up to 180 degrees. As we have here, angles in a triangle add up to 180 degrees. So 90 plus 38 plus this angle is gonna be equal to 180 degrees. So in order to figure out the size of angle MLN, what we have to do is we have to add 90 and 38. When we add 90 and 38, we're gonna take that sum and subtract it from 180. And so let's do that. So we have 180 minus 90 plus 38. And 90 plus 38 is 128. So we have 180 minus 128. And 180 minus 128 is definitely 52 degrees. And so that means that the size of this angle right there, angle L, is 52 degrees. And that's the answer to this question. Next, our goal is to determine, okay, what is the size or what is the measure of angle MNP? Angle MNP. So we have to figure out, so we have M, right? We have N, right? And we have P, all right? And so we have this particular angle that we're looking at. So M and P. And also note that we're really focusing on the angle in the middle. So we really want to figure out what is the size or what is the measure of angle M, all right? Angle M. So let's highlight that, right? Or let's show it. We really want to figure out what is the size of angle N. Okay, what is angle N? Now, it's important to note that, so this is 90 degrees, okay? And it's important to note that this is 34, this is 52, sorry, 52 degrees from the previous, from our previous answer. We saw that this angle L is 52 degrees, okay? And so this is angle L. Now, in order to answer this question, because we want to figure out what is this angle right here, the first thing that we're going to do is we're going to place our alternate segment theorem. And the alternate segment theorem says the following: the angle that lies between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. And so what does that mean? It says that, it tells us right here that if you have an angle, in this case it's theta, that lies between the tangent, so this black line is the tangent and a chord, it tells us that this angle is going to be equal to this angle that is subtended by the same chord. And so this angle and this angle are equal. Okay, so we're going to use this particular theorem. Notice that this right here, this line is a tangent line, all right? And this MN is a chord. So angle N is the angle that is formed, or the angle that lies between the tangent and the chord. And based on this theorem, it's going to be equal to this angle that is subtended by the same chord. And we know that it's subtended by the same chord because if you notice carefully, that this angle, angle L, the legs of this angle rests on the chord MN, right? So that means that this angle, angle L, is subtended by the same chord, all right? And so that means that if this is 52 degrees, that means that this measure, or the size of this, is also 52 degrees. And so that means that angle MNP is actually equal to 52 degrees based on the alternate segment theorem. And that's our answer to this question.